So welcome to this latest video on 162 Math, and in this video we'll be going over the A2 Maths topic of series and sequences by working through some past exam questions. Now as always, I'll include a copy of the questions in a link in the description for you to download, and I strongly recommend you have attempted these questions before watching through this video so you can test your prior knowledge. Now before we get started, let's just have a quick overview over some of the key formulas and some of the key things you need to know about each of the series and sequences covered in this particular topic. So starting with an arithmetic series, you need to know what the nth term is, which is un equals a plus n minus 1d, and the sum of n terms. For a geometric sequence, you've got the nth term, the sum of the n terms formula. We've also got the sum to infinity when r is between -1 and 1, inclusive of those numbers. And here we've got each of those formulas. Now the good thing for you to note is that all of these formulas are given to you in the formula book. The only one that is an exception is when you've got the nth term, when you've got r to the n is in the formula, but you've also got the sum of n terms as you would have with the arithmetic series, and you've got the sum to infinity. Now when it comes to iterative sequences, here you need to know how to find the following terms. So for example, when you're given u1, you need to find u2, u3, u4. You need to know the different types of sequences, so you know and recognize when a sequence is going to converge, diverge, oscillate, repeated, etc. You also need to know how to find the period of a repeated sequence, so when it starts to reset, how many terms does it reset. And you also need to know how to find the solution when it converges to a particular value, and you also need to know how to find the limit when it does converge to. So the solution and the limit tends to be the same thing. However, when it comes to limit, it's a case of finding out what the sum to infinity is going to be for that. So when n tends towards infinity, what will the actual term become? Now the next thing you then need to know is sigma notation. Now with sigma notation, there are three general components. So this component here is your starting term, so your starting position. Now sigma basically means the sum of, so this little sigma notation basically means the sum of, or the running total. So therefore, with the complete sigma notation, you want to use a calculator, because now this function is available for you to simply input the values into your calculator and give you the answer straight away. But also, if you are given algebraic terms, what you want to do is you want to relate it to the sum of n terms of an AP if the function is an AP, or a GP, or the sum to infinity if the top limit is infinity, which kind of leads us on to this number here. So this number here is the final term that you want, or the top term, and then finally this here is the actual expression, so the function. Let me use a different color. So this here is the function to calculate the terms. And again, if you've got the Casio FX991EX calculator, you can just simply substitute the values in and it will give you the answer. And mark schemes now are going to be awarding less marks because of this feature on your calculator. Now before we get started working through these questions, a little note to remind you that a copy of these questions are available for you to download in the description below, which I strongly recommend you do, and have an attempt at these questions just to test your current knowledge. So looking at question 1, it says that a sequence is defined by u1 equals a and un plus 1 equals -1 times un, and the question is asking us to find the sum of the sum of the first 95 terms of un, and it says circle your answer. Now this one's only worth 1 mark, so hopefully it shouldn't require too much work. So here we know that u1 equals a, so then working out u2, all we've got to do is substitute it into this formula, so it's going to be -1 times the previous term. So this is going to be -1 times a, which is -a. Then for u3, we're going to do -1 times the previous term, which is -a, which is going to give us +a, and so forth. So what we notice is that the first couple of terms are going to be a, then it's -a, then it's +a, then it's -a. Now when we've got u is a positive number, or should I say an odd number, then we end up with a +a, and when we've got u is an even number, we end up with a -a. Now here you can see that when we were doing the sum, we're going to end up with a plus minus a plus minus a, and eventually, because we know that u to the 95 is going to equal positive a, we know we're going to end up with a positive a. So therefore what's going to happen is that all the a's are going to slowly cancel up, and all we're going to be left with is a single a. So the correct answer is a. Moving on to question 2, it says consecutive terms of a sequence is related by un plus 1 equals 3 minus un squared. In the case that u1 equals 2, find u3. So first things first, we need to find u2. So u2 is going to be 3 minus the previous term, which is 2 squared. And if I type that in or work it out, I'm going to end up with an answer of minus 1. Then typing in u3, we get 3 minus the previous term, which is minus 1 squared, and again if I work all that out, I'm going to get an answer of 2. So 2 is my value of u3. It then says find u50. Well, again, looking at the terms, u1 was 2 and u2 was minus 1, u3 was 2, and u4 will, following the pattern, is going to be minus 1. So when n is an odd number, I'm going to end up with 2, and when u is an even number, I'm going to end up with minus 1. Now 50 is even, so I know that u50 is going to equal 2. Then for B, it says state a value of u1 which gives the same value for u50 as found in AII. So for this, all you need to do is basically give a correct value, but an example of this could be, let's say, minus 2. So if you substituted u1 equals minus 2, then u50 would still end up being positive 2. But again, if you found a different value, that would be fine. So for example, you could have root 2, and that would work fine as well to give you what they're looking for. Now moving on to question 3, it says given u1 equals 1, determine which of the following formulae below defines an increasing sequence when n is a value that is greater or equal to 1. Circle your answer. Now for this, all you need to do is just basically substitute the numbers into your calculator and write down the first couple of sequences and see which sequences is where the terms are increasing. Now if you do that correctly, you should find that the answer is going to be our second option. Moving on to question 4, it says the nth term of a sequence is un. The sequence is defined by un plus 1 equals pun plus q, where p and q are constants. The first two terms of the sequence are given by u1 equals 96 and u2 equals 72. The limit of un as n tends to infinity is 24. Show that p equals 2/3. So for this, using this bit of information here, we can then substitute this into the formula, in which we get 72 equals the previous term, which is 96, and then we get p plus q. So this is one formula that we have got. Then using the second bit of information here, we know that the sum to infinity tends to 24. So when un tends to L, which is the limit, we end up with L equals LP plus Q. Well, we know that the limit is going to be 24. So we've got 24 equals 24p plus q. So if I just put a little box around that, and there you can see that I've got two equations with two unknowns. So what I need to do is use simultaneous equations to solve this. So if I just write down those two equations, so I've got 72 equals 96p plus q. I've got 24 equals 24p plus q. Now I can either use a calculator or use some algebraic skills to work that out, but basically I'm going to get 48 equals 72p. So then here we get p equals 48 over 72, which equals 2/3. And again, I could have used my calculator to work out p, and it also would have given me q as well. Moving on to B, it says find the value of u3. Now for this, if I just recall back the two formulas, so I had 72 equals 96p plus q and 24 equals 24p plus q. I can then solve them simultaneously by taking the two equations away, in which I end up with p equals 2/3 as found in part A, and for q I end up with a value of 8, not minus 8, 8. So then from this, what we can then do is use these values to then work out what U3 is going to be. So U3 is going to be the U2, which is 72, times P, which is 2/3, plus 8, and I type that all into my calculator and I get an answer of 56. Then moving on to question 5, it says an arithmetic sequence has the first term of A and a common difference of D. The sum of the first 16 terms of the sequence is 260. Show that 4A plus 30D equals 65. So looking at this and using this bit of information here, we know that we've got 16 over 2 equals 2A plus n minus 1D, and that equals 260. So simplifying all of this, we get 8, then we get 2A plus, now n we know is 16, so we've got 15D equals 260. Then expanding the brackets out, we get 16A plus 120D equals 260, and then dividing everything by 4, we get 4A plus 30D equals 65, which is what they wanted me to show. Then for part B, it says given that the sum of the first 60 terms is 315, find the sum of the first 41 terms. So using this bit of information here, we know that we've got 60 divided by 2, and then we've got 2A plus, and then n equals 60, so that's going to be 59D, and that equals 315. So simplifying all of this, we get 60A plus 1770D equals 315. Now if I then bring back the formula from part A, so if I then bring part A out, I get 4A plus 30D equals 65. So then if I then solve this simultaneously, by using simultaneous equations again on the calculator, I get an A value of 20 and a D value of -1/2. So in using these two bits of information, we can then work out the sum of the first 41 terms. So S of 41 is going to equal 41 divided by 2, and then it's going to be 2 lots of A, which is 20, plus N, which is 41. So it's going to be 41 minus 1 and times D, which is -1/2. And if I plug that all into my calculator, I get an answer of 410. Then moving on to part C, it says Sn is the sum of the first n terms of a sequence. Explain why your value you found in part B is a maximum value of Sn. Well, for this, the terms, if you write something along the lines of the terms before the 41st term are all positive. After the 41st term, the terms are negative. So therefore, after the sum of the 41 terms, the sum will start decreasing. So therefore, if I can spell it, the 41st term is the maximum value. And there we go. Now moving on to question 6, it says that a geometric series begins 420, 294 and 205.8. Show that the common difference, common ratio I should say, of the series is 0.7. So for this, all we need to do is just divide two consecutive terms together. So here we get that R equals 420 divided by 294, and that equals 0.7. It then says for part AII, find the sum to infinity of the sequence. Well, here we know that A equals 420 and we know that R is 0.7. So here the sum to infinity is going to be 420 divided by 1 minus 0.7. And if I type that all into my calculator, I get an answer of 1400. Moving on to AIII, it says write down the nth term of the series in the form of P times Qn, where P and Q are constants. Now the key thing to notice here is that with this particular value here, we're not wanting P times Q to the n minus 1, which is the nth term of a GP. So here we know that A equals 420 and we know that R equals 0.7. So here, if you know that the formula in this form is going to be AR times R to the n, then you can just simply substitute that in and you'll get the answer straight away. So here you'll end up with 420 divided by 0.7 times R, which is 0.7, to the n, which gives us a final answer of 600 times 0.7 to the n, which is our final answer. Now if you're not sure and you're not familiar with that formula or you've not been taught it, then here if I substitute a 420 times 0.7 to the n minus 1. Now what I'm going to do is I'm going to work with this. Now this 420 times, now if we use indices, then when do we take away? When we're dividing. So that's going to be 0.7n divided by 0.7 to the power of 1. Now what does this look like? Well, it looks like 420 times 0.7 to the n over 0.7. Well, I can then take that 0.7 over to the side, so that becomes 420 times 0.4 to the n over 0.7, and then this then becomes 420 over 0.7 times 0.7n, which again gives me the same answer of 600 times 0.7 to the power of n. Then for B, it then says the first term of an arithmetic series is 420. The common difference of the series is minus 8. The nth term of the series is un. Write down an expression for un. So for this, we're using a plus n minus 1d. So substituting numbers in, I get 240 plus, and then we get n minus 1 times minus 8. Then if I expand the brackets, I get 240 plus minus 8n plus 8, which gives me 248 minus 8n. Then for question BII, it says given that UK equals 0, find the value of the sigma un with the limits of 1 to k. Now for this, what we need to do is, well, basically substituting this or replacing un, we get sigma of k of n equals 1 of 248 minus 8n. Now for this, if we substitute k in, so when n equals k, uk equals 0. So therefore, what I get is 248 minus 8k equals 0, and then from this I can then work out what the value of k is going to be. So 8k equals 248, so k equals 31. So then from this, what I can then do is substitute that into this expression here. So I get sigma 31, n equals 1, and I've got 248 minus 8n. Now I can substitute this straight into my calculator, replacing n with x, in which I get an answer of 3,720. Now moving on to question 7, it says that an arithmetic series 23 plus 32 plus 41 plus 50 plus, and then it goes to 2,534, has 280 terms. Write down the common difference of the series. So for this, to find the common difference, all we need to do is just basically, as it's an arithmetic series, is basically take away two consecutive terms together. So if we just find the difference, we notice that the common difference here is going to be plus 9. Then says find the 100th term of the series. So for this, all we need to do is basically, we know that the first term is 23. We know that the common difference is 9. So to find u of 100, not s. Let me get rid of that. So to find u of 100, all we've got to do is then use the formula of a plus n minus 1d and substitute those in, so we get 23 plus 99 times 9, and if I type that all into my calculator I get an answer of 914. Then moving on to C, it says the sum of the 280 terms of the series. We'll find the sum of the 280 terms in the series. So for this we're using the formula of n over 2 2a plus n minus 1d. So substituting the values, so we know that a is 23, we know d is 9, and we know n is 280. So then substituting those numbers in, we get s of 280 is going to be 280 divided by 2 times a, which is 23, plus n minus 1, so that's going to be 279 times 9, and if I type that all into my calculator I get a number of 357980. So then moving on to question 8, it says then infinite geometric series has a common ratio of r. The first term of the series is 10 and its sum to infinity is 50. Show that r equals 4/5. So for this we know that using this bit of information here, we know that an a is 10, we know r is r, and we know that the sum to infinity, the formula is a 1 minus r. So substituting those numbers in, we get that the sum to infinity is 50, and we know 10 over 1 minus r. So using this substitution, what we're going to do is then find out what r is. So if I put brackets around the 1 minus r, we get 50, 1 minus r equals 10. So I've got 50 minus 50r equals 10. I can take the 50 out to the side, so I end up with minus 50r equals minus 40. So r equals minus 40 over minus 50, which simplifies to give me 4/5. It then says find the second term of the series. So for this, the second term, so s on a u of 2, I should say, is going to be a times r to the 2 minus 1. So substitute the numbers in, we know that a is 10 and we know r is 4/5, so it's going to the power of 1. Typing that all into my calculator, working it out, I get an answer of 8. Then moving on to question B, it says the first and second terms of the geometric series in part A have the same values as the fourth and eighth terms respectively of an arithmetic series. Find the common difference of the arithmetic series. So for this, we know that from the GP, the first term was 10, and we know that the second term was 8. So then finding the fourth term of an AP is going to be using the formula of a plus n minus 1d, which is the nth term of an AP. So substituting that in and swapping the values of n equals 4, so that's going to be a plus 3d, because 4 take away 1 is 3, and that equals 10. Then the eighth term, which is when n equals 8, is going to be a plus 7d is going to equal 8. So then using this bit of information and recognizing that it's going to be two simultaneous equations, I could then go on to solve this. So using my calculator, I get a equals 23 over 2, which is 11.5, and d equals minus 0.5 or minus a half, so d equals minus 0.5. It then says for part 2, the nth term of the arithmetic series is un. Find the value of the sum of the first 40 terms. So for this, we've got sigma, and we've got 40, and we've got n equals 1. Now the nth term of the arithmetic series, well, I only know what a and d are. So a was 11.5 and d was minus 0.5. So the nth term is going to be 11.5 plus n minus 1 times minus 0.5. So then substituting that in, I can either write it in all its entirety, so I've got 11.5 plus, and then just expanding the brackets, I'm going to end up with minus 0.5 n, and then we've got plus 0.5, and then typing that all into my calculator. So if I type in all of this using the sigma function on my calculator, I get an answer of 70. Then moving on to question 9, it says the sum to infinity of a geometric series is 96. The first term of the series is less than 30. The second term of the series is 18. And for part 8 it says find the first term and the common ratio of the sequence. So looking at this bit of information here, we know that a over 1 minus r equals 96. We know that a has got to be less than 30. And we know that the second term of a geometric series, so that's going to be a times r to 2 minus 1 equals 18. Well, simplifying all of this, we get that as a times r. So we know that AR equals 18. So let me just put little boxes around those key bits of information. Now to find R, what we can do is we can use this and this bit of information here to find out what R is going to be. So here we know that A1 minus R equals 96, and we know that AR equals 18. So then if I make one letter the subject, so let's go for A, we get A equals 18 over R. So then if I now substitute this into this, then what I get is I'm going to get 18 over R all divided by 1 minus R equals 96. Now if I put brackets around this bit here and take this over, then what I end up with is 18 over R equals 96 minus 96R. Then if I multiply out the R, we get 18 equals 96R minus 96R squared. Then if I take all of this over to the left hand side, we get 96R squared minus 96R plus 18 equals 0. And lo and behold, that slowly now starts to look like a quadratic. So what we now need to do is solve the quadratic, which can be easily done using your calculator, in which I get an R value of 1/4 or 3/4. Now for this, we then need to know which ratio we need to use then. So here we know that AR equals 18. So when R equals 1/4, we get an A value of 72. And when R equals 3/4, we get A value of 24. Now from this, if we go back to the original start of the question, we know that A must be less than 30. So out of these two values, it can't be this, as A is less than 30, so A therefore must equal 24. So here we get an R value of 3/4 and an A value of 24. Then moving on to BI, it says that show that the nth term of the series UN can be written as UN minus 3 to the power of n all over 2 to the power of 2n minus 5. Now this one is not a nice question, I must admit, but let's have a look at what we're looking for. So we know that UN, based on the information that we're given, is 24 multiplied by 3/4 to the power of n minus 1. Now for this, what we need to do is we need to write the variables as 3's and 2's, as you can see, because that is what we've got in our show that. So I can rewrite 24 as 3 times 2 to the power of 3. So that takes care of the 24. Now the confusing part here, or one of the confusing parts I should say, is then working with this. Now using the rules of indices, we can then work out, we can write this as 3n minus 1 over 4n minus 1. Now 4 we know is 2 squared, so I can rewrite this bit here as 3n minus 1 over 2 squared, and then it's going to be n minus 1, which then becomes 3n minus 1 over 2 2n. I don't know what I'm doing there. And we get 2n minus 2, and that is 3 times 2 to the cubed. So again, I'm just dragging that bit down. Now, lo and behold, I've now converted things into 3's and 2's. However, it's still not quite looking like what they want me to. Now, this is the sneaky thing here. Now, to write 2/3, I can write this as 1 over 2 to the power of minus 3. Now, because that then becomes 1 over 2 to the power of 3, and which then becomes 2 cubed. Now, rewriting this 2 cubed as this, so I can write that as that, I then get 3 times 1 over 2 to the power of minus 3 multiplied by 3 to the power of n minus 1 over 2n minus 2. Now, if I just write 3 as a fraction, you can see there that I've got lots of fractions being multiplied together. So that then becomes, well, looking at the numerator, that becomes 3 times 3n to the minus 1 over 2 to the power of minus 3 times 2 to the power of n, 2n minus 3. Now, looking at this, I can then use the rules of indices. When I'm multiplying, I add the powers. So n minus 1, so that becomes 1 plus n minus 1, which then becomes 3n. And the bottom bit becomes 2 to the power of 2n minus 3, and that should be minus 2. I don't know, I can't read my own handwriting there. That should be a 2. And then that then becomes minus 3 minus 2. And there we go. So minus 2 minus 3, which then equals 2 to the power of 2n minus 5. And lo and behold, I've now made it look like what they wanted me to. Then for part 2, it then says, hence show log 3 un equals n 1 minus 2 log to base 3 2 plus 5 log to base 3 2. So for this, what we need to do is we know that un equals 3n over 2n minus 5. Now if I take the log 3 of both sides, so I get log 3 of un equals log 3 of 3n over 2n minus 5. Then using the rules of logs, I get log 3, and then here we get 3n minus log 3 of 2n minus 5. Now if I put the powers in brackets, this then becomes n log 3 of 3 equals, minus, and then moving this power to the front, we get n minus 5 log 3 to the 2. Now log 3 to the base 3 is just 1. So that then becomes n minus, and then we've got n minus 5 log 3 2. Then expanding the brackets, I get n minus n log 3 2 minus 5 log 3 2. And then I can then factorize these two things here, in which I get n 1 minus log 3 to the 2 minus log, actually that should be a plus, that should be a minus rather, and that should be a plus, and we get plus 5 log 3 to the 2, which is what they wanted me to show. Then moving on to question 10, it says a geometric series has the first term of 80 and a common ratio of a half. Find the third term of the series. Well, the third term of a GP is going to be a times r to 3 minus 2. So u3 is going to be 80 multiplied by a half to the power of, I don't know why I wrote 2 there, that should be a 1, squared. And typing that all into my calculator, I get an answer of 20. It then says find the sum to infinity. Well, sum to infinity is a over 1 minus r. So substituting those values in, I get the sum to infinity equals 80 over 1 minus a half. And typing that all into my calculator, I get 160. Then it says for part C, find the sum of the first 12 terms of the series. Give your answer to 2 decimal places. So here I know that A equals 80, R equals a half, and N equals 12. So then the sum of the first 12 terms is going to be 80, 1 minus 0.5 to the power of 12. And what's happened there? All divided by 1 minus r, which is a half. And that, typing that all into my calculator, I get an answer of 159.960937, which rounded to 2 decimal places is 159.96, and that's to 2 decimal places. Then moving on to question 11, it says the nth term of a geometric series is un, where un equals 48 and then multiplied by a quarter to the power of n. Find the value of u1 and the value of u2. So for this, first of all, to work out u1, we just substitute 1 into the formula. So we've got 48 multiplied by a quarter to the power of 1. I don't know why I've put that there, so let me just correct that. It's the power of 1. Typing that straight into my calculator, I get an answer of 12. Then for u2, it's going to be 48 times a quarter to the power of 2. And type that into my calculator and I get an answer of 3. It then says find the value of the common ratio of the series. So here I've just got to divide the 2 consecutive numbers together. So here the common ratio is going to be 3 over 12, which gives me a quarter. It then says find the sum to infinity of the series. Well, I know that A equals 12. I know that R is a quarter. So find the sum of infinity, I'm going to use A over 1 minus R, which is 12 over 1 minus a quarter. Type that all into my calculator and I get an answer of 16. Then moving on to question D, it says find the value of, and it's given me that the sum of the 4th terms take away sum to infinity. So for this, what I need to do is I need to know, to work this out, this is going to be the sum to infinity minus the sum of the first 3 terms. Now I know that the sum to infinity is part C. Don't know what has happened there. So this is the answer in part C. So this is what I then need to work out, which is the sum of the first 3 terms. So the sum of the first 3 terms, again, I'm going to use the formula of A 1 minus r to the n all over 1 minus r. So here I've got the first term, which is 12, and then 1 minus a quarter to the power of 3, all divided by 1 minus a quarter. Now if I type that all into my calculator, I get an answer of 15.75. So then to work out the sum, where the first term is the 4th term and sigma, and I've got un, which is 12 times a quarter to the power of n minus 1 is going to equal the answer in part C, which was 16, minus 15.75, which leaves me with a final answer of 0.25. Then moving on to question 12, it says a geometric series has a second term of 375 and a fifth term of 81. Show that the common ratio of the series is 0.6. So looking at the second term, well, we know that the second term is AR, so that equals 375, and we know that AR to the 4 equals 81. So if I then do AR to the 4 over AR, that's going to equal 81 over 375, which then cancels down to give me R cubed. Now R cubed is going to equal 27 over 125. So therefore r is going to equal 3/5, which is 0.6. Moving on to the second part, it says find the first term of the series. Well, I know that AR equals 375, and I now know that R equals 0.6. So here A equals 375 divided by 0.6. So therefore A is going to equal 625. Then it says for part B, find the sum to infinity. Well, I know that A equals 625. I know R equals 0.6. So then the sum to infinity is A 1 minus R. So then that then becomes 625 divided by 1 minus 0.6, and type that into my calculator. I get an answer of 1562.5. Then moving on to part C, which was very, very similar to the previous one. So here we've got our first term of 6. So this is going to equal the sum to infinity minus the sum of the first 5 terms. Now this is the answer in part B, and this is what I then need to work out. So the sum of the first 5 terms is going to be 625, and then 1 minus 0.6 to the power of 5 all over 1 minus 0.6. And if I type that onto my calculator, I get an answer of 1441. So then here to work out what they've asked me to do, so sigma n equals 6 of infinity of un is going to equal 625 or 1562.5 minus 1441, and that gives me an answer of 121.5. Then moving on to question 13, it says that the second term of a geometric series is 48 and the fourth term is 3. Show that one possible value of the common ratio r of the series is minus 1/4 and state the other value. So for this we know that AR is going to equal 48 because that's the second term. And we know that the fourth term, which is AR cubed, is 3. So then to work out R, we do that, which then comes up to give me 3 over 48, which is equal to R squared. So therefore R is going to equal, or R squared equals 1/16. So R equals plus or minus 1/4. So R equals minus 1/4 or positive 1/4. Moving on to B, it says in the case when R equals minus 1/4, find the first term. Well, we know that AR equals 48. So A is going to equal 48 divided by minus 0.25 or minus 1/4. So we get A equals minus 192. Then it says find the sum to infinity. Well, we know that the sum to infinity is A over 1 minus R. So the sum to infinity is going to be minus 192 over 1 minus 1/4. And again, typing that all into my calculator, I get an answer of minus 153.6. Then moving on to our last question, it says use logarithms to solve the equation of 0.8r equals 0.05. Give your answer 3 decimal places. So taking the log of both sides. Now it doesn't really matter what base you have for logs. I'm just going to use normal 0.8x equals log of 0.05. Then we take the x to the front, so we get log of 0.8 equals log 0 of 0.5. And so x equals log of 0.05 over log of 0.8. And then typing that all into my calculator, I get an answer of 13.425, and that's to 3 decimal places. And again, if you are using log to the base, just make sure your bases are the same, but you should get the same answer. Alternatively, if you've got the Casio 9x FX991 EX calculator, if you just press Shift and the negative button, you should come up with a preloaded log button. Then says for question B, the infinite geometric series has a common ratio of r. The sum to infinity of the series is 5 times the first term of the series, so that show that r equals 0.8. So using the bit of information, we know that the sum to infinity is a over 1 minus r, and we know that the first term is a. So what we know is that the sum to infinity is 5 times the first term, so that's what we've got so far. Now if I put brackets around that and take that over to the other side, end up with a equals 5a 1 minus r. Then if I divide both sides by a, I end up with 1 equals 5 lots of 1 minus r. So expanding the brackets, I get 1 equals 5 minus 5r. So minus 4 equals minus 5r. So r equals minus 4 over minus 5, which equals 4 over 5, which equals 0.8. Then moving on to part 2, it says, given that the first term of the series is 20, find the least value of n such that the nth term of the series is less than 1. So here we know that a equals 20. So from this we know that a times r to the n minus 1 is less than 1. Now, substituting the values in, we know that r equals 0.8. So we've got 20 times 0.8, n minus 1 is less than 1. So then we've got 0.8 n minus 1 is less than 1 over 20. Then if I take the log of both sides, I end up with log of 0.8 n minus 1 is less than log of 1 over 20. Then if I take the n minus 1 to the front, so I get n minus 1 log of 0.8 is less than log of 1 over 20. Then take the log 0.8 to the side, so I end up n minus 1 log of 1 over 20 divided by log of 0.8. So then I get n is less than log of 1 over 20 over log of 0.8, that is a point, plus 1. And then if I type all of this into my calculator, I get a value of n is less than 14.425 blah blah blah. Now here the 14th term, if I type it in, so I get 20 times 0.8 to the power of 13, and that equals 1.0995. And then if I work out the 15th term, that's going to be 20 times 0.8 to the power of 14, and that equals 0.8796. So as you can see, in terms of this, which is the first term, that's going to be less than 1. So here we know that n equals 15, and there we go is our final answer to our final question.